In this lecture, we'll learn about object-oriented programming and how to implement this in Matlab. Objects are variables that have an identity, and the identity is called the class, and functions, which are called the methods, to operate on these objects. To motivate this, let's think about data and how it appears and how that influences what we think it represents. Take a 3x1 column vector. Does it represent a date or a point in three-dimensional space, perhaps specified in Cartesian coordinates or cylindrical coordinates or spherical coordinates? Or is it a quadratic polynomial? Or maybe something else? Those are several different identities that could be associated with a 3x1 column vector. What functions make sense on those pieces of data? Two dates can be subtracted to yield the number of days between them. An integer can be added to a date to get a date in the future. For points in three-dimensional space, there's a notion of negation, the distance between points. Points can be added and subtracted if they're interpreted as components of a geometric vector. Polynomials can be added, subtracted, multiplied, differentiated, integrated, evaluated, and so on. These are the different methods that apply to the different identities. So classes give data an identity and associate and define functions to that identity and disallow other functions. For instance, we would not be allowed to multiply two dates together, even though subtraction of dates makes sense. Objects are instances of the class. The most common class that we've seen in Matlab is double. An instance of a double is, for instance, this 3x2 array M. Another common class in Matlab is the cell array. Here's a 3x2 cell array. Now both of these classes have the method size, and they both use identical parentheses referencing methods. Those expressions make sense, as do those referencing expressions. However, only plus makes sense for double, and curly referencing only makes sense for cells. M plus M is legal, but C plus C is not, as there is no addition concept for cell arrays. Likewise, a 3-2 contents reference for C makes sense, but a 3-2 contents reference for M does not, as there's no contents referencing for doubles.